Hello everyone, welcome to my programming club. Today we will be solving another daily lead code problem, and the problem's name is unique length-3 palindromic subsequences. So you are given a string S. You have to return all the palindromic subsequences of S which are of length 3, and those should be unique. Okay, so those of you who do not know what a palindrome is a string that reads same forwards and backwards. Okay, and those of you who also don't know what a subsequence is a string. Subsequence of a string is a new string generated by deleting some or none of the characters of the original string without changing the order. So let me explain a palindrome and a subsequence for those of you who do not who are new to these terms. Uh, Palindrome is something like this. If you read from left to right, then it will be ABA, and if you read from right to left, it will be ABA. And let's consider ABC. So if you read left to right, it will be ABC, and if you read in this fashion, then it will be CBA. As you can see, these two are different things. This is left to right, and this one is right to left. So they are not same. So it's not a palindrome. It is a palindrome. Okay. So these two are equal. So palindrome, I hope it's clear to you. And now coming towards what a subsequence is. Subsequence of a string particularly. So let's say string is given A, B, C, D. Then if you delete, let's say B, without changing the order of A and C, A, C and D, your subsequence can be A, C, D. Also, if let's say you do something like this, after deleting B, you change the order. Instead of C coming first, coming before D, you write D before C. Now this is not a valid subsequence since the relative order of these two in the original string is different from the subsequence that you are trying to generate. So it should be kept in mind that uh, the order of the remaining characters that are not deleted should not be changed. Okay, so I hope the sequence is also clear to you. And now let's move further in the problem. Uh, okay, so unique palindromic subsequences are to be returned whose length is 3. Let's have a look at the constraints. So length of the string will be of order 10 is to power 5. Okay, and S will consist of only lower English letters. So usually in this type of questions, the end to solve the particular problem lies there in the constraints itself. So it's mentioned that only lower English letters will be there, lowercase English letters. Okay, so lowercase English letters are 26 in number. Okay, and what will be a brute force way to solve this problem? Force way can be easily you finding the occurrences of first and the last occurrence of a, well, it's not exactly brute force, but what you will do, you will fix one pointer to the first occurrence of a number. Or I think you can generate all the subsequences and then see generate all subsequences and check among those which ones unique and whose length is 3. Okay, so even to generate all the subsequences, okay, you will be requiring time in the order of 2 raised to power, let's call the length of s as len, 2 raised to power len time, something in order of 2 raised to power len. Okay, so if this is the maximum length possible, then 2 raised to power 10 raised to power 5 is a huge number as compared to 10 raised to power 8 operations limit. And those of you who do not know what this operation limit is, basically in 1 second, 10 raised to power 8 operations are allowed in your program. And if the number of operations in your program reaches equal to this limit or become exceeds this limit, then you will get a TLE. These are number of hops to find all subsequences. So it will be higher in general. Brute force will be higher. You will also be checking for which subsequences are unique and are of length 3. Okay, so this will definitely give you TLE, time limit exceeded, and your solution will not be accepted. For this particular limit concept, I will be providing you a link of article describing how the time complexity of an accepted solution varies according to input size. Okay, so moving back towards the solution, so we should be optimizing this brute force approach. Okay, this brute force approach needs optimization. So let's see the optimized approach. Okay, so to do the optimization, what you can observe is if you know that a character in string is occurring twice or more times, then you can apply the following operation. Do the following. What we will do, first of all, we will store the first and the last occurrence of the character. So if you consider this character, the subsequences starting from the first character and ending at the last occurrence of this character, starting from the first occurrence and ending at the last occurrence. Okay, consider all subsequences starting at occurrence and ending at last occurrence. Okay, so if you consider them, then you can easily return how many number of palindromes this particular character will be contributing to the answer. How many number of palindromes of length 3 this character will contribute towards can be easily find out by counting uh, unique characters between starting and ending occurrences. Counting unique characters between start and indices. Okay. So for example, let's take an example to understand our algorithm. Okay. Let me quickly take another slide. So let's take this example double A B C A. Okay, double A B C A. Now let's mark the indices 0 1 2 3 4 0 1 2 3. Okay, so if you search for A, then it is occurring twice. The starting index and the ending index. Starting index being 0 and ending index being. Or let's take another example. I think it's a very simple one. Yeah, I think this will be a more suitable example. Okay, this is having some characters which are occurring more than twice, and there are some characters in between them. Oh, so 0, 1, 2, 3, 4, 5, and 6. So for A, starting and ending index, and then for B, starting and ending index, and then for C also. C is occurring only once, so we are not considering it once occurrence. Okay, so we will not consider it. Only B and A will be considered that are occurring more than twice or more than that. So A is occurring from 4 to 6 and B is occurring 0 to 3. No, 5. Okay, 0 to 5. So this is what we will do initially. And then from let's say this particular index to this particular index, you will count the number of unique characters. and this will be the number of unique palindromic subsequences that B will be generating, while B being the first and the last character of the palindromic subsequences of length 3. Since already we have contributed 2 to the length, we will be contributing length 2 to the palindrome of length 3. So we need to find only the unique characters, and then we can easily tell how many unique palindromes will this be generate. Okay, so overall your time complexity, if you may ask, will be of order, let length be the length of the string given to you, and 26 characters are there in English alphabets, small case letters. So this will be the overall time complexity. So the length is of order 10 is to power 5 and 10 into 26. So it will be smaller than 10 is to power 8 operations. Okay, then you can easily see that your solution will be accepted. So these are the number of operations of solution. So you will get accepted solution here. Okay. So let's see the implementation quickly. Here we will be storing the first and the last occurrence of each character. In the given string. Okay. So after that, you will count the palindromes. First of all, you should be uh, here you are just counting the first and the last occurrences of characters. This will be when you are seeing the character for the first time. Moving from left to right, or say traversing from left to right. Okay, and this is when you are seeing the character, not the first time. You have seen this character earlier also. Okay, and once you are done with populating the characters with their first and the last indices, you will be counting the number of palindromes. Number of palindromes. Each character occurring twice or more times in the given string S will be contributing to. Okay. Number of palindromes of length 3 you can say. Okay. So between the first and the last occurrences, you will be counting the number of unique characters. between the first and last occurrences of the current character, you will be counting number of unique characters. Okay, and that many number of unique length-3 palindromes will be generated. That many number of palindromes, unique palindromes length-3 will be generated, which will contain current character as the first and last character. Okay, so you will be adding that to the palindrome count, adding this number to the overall palindrome count, length-3 palindrome count. And then you will at last return your palindrome count. At last, you will be returning the palindrome count. So this is how we will be solving the problem. If you are having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer. Before ending the video, let's try to submit it once. I have already checked it for the sample test cases. So as you can see, it's getting accepted. So thank you for watching. Have a great day ahead.